और ladies and gentlemen, let's move forward and अब मैं request करना चाहूँगी Mr. Imra Alf को for the presentation on efficient soybean dehulling, sharing practical strategies to optimize dehulling performance. Over to you.
Hello everyone. First of all, it's a great pleasure and honor to be here at the SOPA and in this beautiful city. So to me, I'm Imra Alp. I'm joining from Bühler, Switzerland. For those who don't know Bühler, so Bühler is a global technology provider with over 160 years of history. So we provide solutions for the food, feed, and as well for advanced material solutions. So you can find our solutions behind almost each everyday product, from, let's say, from pasta, chocolate production, feed production, oilseeds processing. So today I will explain about efficient soybean dehulling. So first of all, what you see here is an overview about the oilseed compositions for soybean and as well for the two other major oilseeds processed globally. So why I'm showing you this? This is important if you design a dehulling plant. You need to know which kind of, what are the specifications of your raw material. Because to make an efficient dehulling process, there are different ways, which I will explain you later, but especially moisture content, protein content, and hull content is very important to know before you design your process. So what are the objectives of the dehulling? So first, reduction of the fiber content by removing the hulls. This will then increase your protein content at the end in the meal. The protein content of the meal depends as well on the protein content of your incoming seeds. Further, if you make intensive dehulling, you need as well to have a hull control later on to control your hulls to avoid oil losses with small kernels which you remove during dehulling. If we see the different processes, especially for soybean, so we have majorly two different processes to dehull the soybean. One is the cold dehulling, and the other is the warm, or in some cases, hot dehulling, which will apply. So when to use which process is mainly depending a little bit on the moisture content as well. So for soybean with incoming moisture content of 9 to 10%, it's rather used a cold dehulling process. And if you have incoming soybeans, 12, 13%, so it's rather going to warm dehulling. And in some areas, when you process soybean directly after harvest, you have 14, 15, then you might need to consider a hot dehulling. So importance of the moisture content here on the graph, you can see the moisture content of the soybean and how much the kernels are adhering to the hulls. So the ideal moisture of a soybean when you're going to dehull is between 8 to 9% on cold dehulling. With this you can remove the most of the hulls. So if you are processing then soybean with higher moisture, you will be having a lot of kernels sticking to the hulls, and it will be then more difficult to remove the hulls from the beans. And it's possible, but then you will have as well a lot of hull contents, oil losses. If you dry the soybean before as well, the tempering time is also important. If you dry, after drying, you need approximately 36 hours tempering time so that the soybean moisture is equivalent distributed through the whole kernel. Here you can see the two dehulling processes, cold dehulling on the left side and warm and hot dehulling on the right side. So usually the incoming soya is in average 12 to 13%. Afterwards you are going to clean it. And then by cold dehulling, as I mentioned, if you want to have an efficient dehulling, so you need a moisture content 8, 9 in these ranges. So then you need to apply a drying, and afterwards it will be tempered and then cracked in cracker mills, and the hulls will be removed by separators, which are then going into a hull control section where we recover the small kernels which have removed as well with the hulls. Afterwards, before flaking, you need to condition the soybean again, because ideally for flaking soya is you need to have a temperature of around 65-70 degrees to have good flakes and to not create a lot of fines, which in the end will affect your extraction. So cold dehulling is usually lower in capex if you do, but it is higher in operation costs, in OPEX, because you need to apply twice, you have twice energy consumption mostly on, by drying you consume power, and then also for conditioning you have again high energy consumptions. When we come to warm dehulling, in warm dehulling we can directly process soybean with 12 to 13%. After cleaning, the soybean will be conditioned in a conditioner directly from beginning to 65-70 degrees. And with that also the moisture will be removed. And then from then on the whole process, target is to keep the product hot until the solvent extraction. So that's for warm dehulling. If you have hot dehulling with very high moisture product soybean, so then you can also apply hot dehulling. This would be an additional fluid bed where with hot air we can crack the soybean more. Then warm dehulling compared to cold dehulling is applied in two stages. In the first stage we crack the soybean in half. It goes then into a dehuller aspirator where we remove the hulls, and then in the second cracker we make 1/4 and 8 beans, and again it will be dehulled, and then it goes to the flaking and to the solvent extraction. Here you can see two different process flow diagrams, how a layout looks like. So on the left side is the cold dehulling with a cracker, usually a double-stage cracker, followed by dehulling sieves. And usually, of course, it depends then always on the raw material which you process. It's usually below 2% rest hull, possible to dehull. And for higher protein, more efficient dehulling, but of course it depends on what I mentioned in the beginning on the moisture content. If we apply hot dehulling or warm dehulling, so that you can see first the conditioner on the top, it's the fluid bed. After this, it goes in the cracker, dehuller, cracker, and again a dehuller. So these are the main machines, which are the key equipments which are applied in both processes. It's basically mainly the same. Both the same crackers will apply it also in cold and warm dehulling. The only difference is then on the hull separation. For cold dehulling we use sieves to remove the hulls, And by hot dehulling, warm dehulling, we use aspiration cascades. This because during warm dehulling, we need to use hot air to keep also the product temperature till to the flaking. And then flaking is then the last equipment in the preparation plant. Here a more closer look to the crackers. So usually in cold dehulling it starts with a double stage cracker. So we have two pairs, one on the top, one on the bottom, where we can make a 1/4 to 1/8 granulation of the seed, and then it goes to the dehulling sieve. So we have usually two kind of rolls, a slow moving roll and a fast moving roll, and depending on your soybean and dehulling degree you want to achieve, we have then different types of flutings on the rolls. So this is then the hull separator for the cold dehulling process. So the product enters on the top. We have two decks of sieves. On the top we have aspiration nozzle. With this you remove the hulls, and as well some kernels will of course come as well, and this goes then into the hull control section, which I will explain later. Here the warm respective the hot dehulling process. So you have a conditioner. If you go for warm dehulling, so minimum 12% moisture is recommended, otherwise you will over dry the product and you can create some fines during cracking and flaking. For hot dehulling you should have a minimum 13% moisture. So after the conditioner on the bottom line, if you have warm dehulling you just go to the cracker, and if you have a hot dehulling you can install also a fluid bed dryer, where we, with 140-degree air, we will pop up the hulls of the soybean, and yeah, it's suitable for when you have high moisture content. Here you have an overview of the aspiration cascade. So this is the dehulling for warm dehulling processes. So product enters on the top, we have a cascade, and with hot air we remove then the hulls. Also very important is secondary dehulling, so we call it hull control, because during dehulling you will always have small kernels or still some kernels which are sticking to the hulls, which you will remove as well. And for this you can apply a hull control section. So there what we do is with centrifugal sieves we detach the kernels which are still adhering to the hulls, we separate them, and with a sieve we remove then the good product, the soybean, which has been removed with the hulls, and feed it back to the main product. And with this you can have then you can reduce your oil loss. So resume, so high pro meal production ensures the highest benefits. This because you have the lowest operation cost, because you just need to heat up the product once, you don't need to dry it. Very important that you know, when you design your dehulling process, that you know the specification of the product which you like to process. As I mentioned, cold dehulling has the lowest capex, but the highest operation cost, and for the warm dehulling it's a different. We have it's slightly higher capex costs, but much less operational costs. And to avoid oil losses, so a hull control can improve your oil losses. So thank you very much. So if you like to discuss this further, so we are here, and you're most welcome to come and to discuss it more deeply. Thank you.
Thank you so much, sir.
Good afternoon. This very good presentation from Mr. Emra Alt. Yes, it's our day-to-day, he discussed about day-to-day issues related to the quality of the seeds and all this one, and how the dehulling is so important for maintaining the quality and to produce edible products from soybean. And this another presentation from Mr. Nagesh that is regarding the oleochemicals, how to give the value to the waste from the refining. So that's what regarding he expressed in detail. So thank you very much to both of them, and thank you to you all for listening patiently. Thank you.
Thank you so much, Amir sir. So ladies and gentlemen, let's move forward. यहाँ से चलते हैं हम आगे जहाँ पे हमारे गेस्ट हमारे साथ हैं.
और अब दोस्तों बारी है हमारे फेलिसिटेशन पार्ट की. सो चलिए शुरुआत करते हैं. अच्छा, सारे लोग सो गए क्या? एक बार जरा तालियों की आवाज़ें सुना दीजिए ताकि हमें पता चले हाँ आप लोग जाग रहे हैं अभी. कम ऑन. ऑलराइट, सो मैं यहाँ पर रिक्वेस्ट करना चाहूँगी सबसे पहले हमारे नागेश सर को फेलिसिटेट करने के लिए चामे सर से. सर प्लीज़ टेक द लीड. तालियां बजती रहनी चाहिए दोस्तों. कम ऑन, थोड़ा जगाना है हमें खुद को. एंड ऑल्सो इमरा सर को फेलिसिटेट करने के लिए चामे सर. एंड नाउ हमारे टाइटल पार्टनर डीवी चामे सर को फेलिसिटेट करेंगे पाठक सर. फोटो सेशन होगा. आशिता मैम का कॉल आ रहा है.